Okay, so here we're just going to go through the definitions of each of these, which is basically the most basic, easiest way to describe each of these shapes. So, quadrilateral. That's any four-sided polygon. So all of these down here are also examples of quadrilaterals. A trapezoid. That has at least one pair of parallel sides. So here I drew them right here and right here. Now, an isosceles trapezoid is a trapezoid, so you have to include this part, but also there's a special property of you also need congruent legs. So we have the parallel sides for the trapezoid, but this leg and this leg are the same length. Now, a parallelogram. That has the opposite sides parallel. So we have this set and this set, both parallel to each other. Now for a rhombus, we have all sides congruent, so all four sides are the same exact length. And a rectangle. All the angles are congruent. All the angles are 90 degrees, so all four of them, 90 degrees. And finally, if you put together a rhombus and a rectangle, then you get a square. So we have all four angles and all four sides congruent to each other. Okay, so now we have a couple examples from old Regents exams. In the first one, it says parallelogram ABCD with diagonals AC and BD intersecting at E is shown below. So here's AC, here's BD, they intersect at point E. Which statement must be true? Well, let's take a look at these things. BE congruent to CE. So that's saying that this must be congruent to this. Now, that's not always the case because we know that the diagonals bisect each other. So like this is possible, or this is true, but we don't know necessarily that this is the same as this. Because, I mean, looking at it right now, this looks a little shorter than this right here. So that's not going to be our answer. The next choice says angle BAE right here is congruent to angle DCE right here. Just follow the letters. BAE, DCE. This is true because these lines here are parallel, making these alternate interior angles. And the alternate interior angles are congruent when the lines are parallel. So this is the answer right here. But let's real quick look at why the other two are not the correct answer. So the next one says that AB is congruent to BC. We don't know that. In a parallelogram, the opposite sides are congruent, but we don't know that the sides next to each other are congruent. So no dice on that one. And the last one says that angle DAE right here is congruent to angle CBE. Now it's like almost sort of thinking maybe an alternate interior thing, but it's just the wrong transversal on this. So like with that transversal, we got this angle, but on that transversal, we get this angle. So we don't know enough about those to say that that's a true statement either. Okay, so more about parallelograms. Look over here and which one is not always true. Diagonals are congruent. I'll tell you right now, that is not always true. The diagonals bisect each other, but they're not necessarily congruent. That would be an isosceles trapezoid, a rectangle, or a square. The opposite sides are congruent. Yes, that's always true. The opposite angles are always congruent, and the opposite sides are parallel. That's literally the definition. So there you have it. So in this example, it tells you that AE, which is just this piece, the diagonal, half the diagonal, is x plus 2. And it tells you that BD, the whole diagonal, is 4x minus 16. Now, one super important piece of information with rectangles is that the diagonals are congruent to each other and they bisect each other. So specifically, if we're looking at AC, we know that this equals 4x minus 16. So essentially, we have AC equals BD, which is represented by 4x minus 16. But how big is AC? We know that half of AC is x plus 2. So to get AC, one thing you can do is 2 times x plus 2. And then that all equals BD, which is 4x minus 16. So from here, we just have to solve the equation for right now. So let's distribute this 2. We get 2x plus 4 equals 4x minus 16. And I'm going to subtract the 2x to get the x's to the same side. That cancels. You're left with 4 equals 2x minus 16. Add 16 to both sides. Cancels out. We get 20 equals 2x. Divide by 2. And x equals 10. Seems like a good answer, but we're not done, because they want the length of AC. Now remember, AC was here, 2 times x plus 2. So AC, 2 times x plus 2, which is equal to 2 times 10 plus 2. 10 plus 2 is 12. And we get that AC equals 24 units.